Hello, my name is Dan and welcome back to the channel. In this video I'm going to cover processing a narrowband project that I've been working on for about 3 months now on the Tulip Nebula and its surrounding region in Cygnus. So what we're going to cover is how we go from the outputs of the stacking all the way through to producing a Hubble Palette image of the Tulip Nebula and adding in the natural star colours using RGB data as well. So let's jump right in. In my previous video, I covered the target selection and the plan for this project and why you should bother with narrowband imaging. I'll pop a little link up above and in the description to that video. I was originally going to do one long video covering the processing too. However, as you can probably tell, the processing is a bit lengthy. There's lots to cover. There's lots to think about, and I just go through pretty much everything in this video. So if you're interested, please do watch ahead. But let me just cover again. So I've popped the exposure timings here. So I just got under 25 hours of total exposure there. Mostly in narrowband, as you might expect, and a little bit of broadband data as well for those natural star colors. So in this video, we're going to jump right in. We're going to open PixInsight. We're going to use the stacked images, and I'm just going to go through all my processes from start to finish of producing the final image, and we'll have a look at it at the end. So my way is not the correct way, it's just how I go about getting my results. I've sort of gathered this from various other tutorials and guides online, mainly from other YouTubers like the Space Koala and Adam Block, for example, or Luca Matico as well. Fantastic channels, definitely go give them a watch. They have amazing content, great videos, and they're super helpful as well. Obviously I try my best as well. If you have any questions about anything I've done in here, like pop them down in the comments and I'll get back to you. But again, it's not to say my way is correct, it's just how I've gone about it, and I quite like the results I got. Hopefully you do too. But yeah, let's jump on over to the PC now and have a closer look. Here we go. So as you can see here, we've got the 6 images. At the top, we've got hydrogen on the left there. We've got sulfur on the right. So let's actually move those around, because I don't know why, but it just makes sense to me to have those red ones grouped together. So we've got hydrogen, sulfur, oxygen, and then on the bottom we've got R, G, and B. So red, green, blue. So the first thing is to label these nicely. So I'm going to call this one H for hydrogen, this one S for sulfur. Obviously this is O for oxygen. Let me just speed this up now so I won't bore you. Okay, so they're labelled properly. So now let's actually have a look at what the images have finally produced by applying what's called an STF, a screen transfer function. So at the moment, the images don't look like there's anything to see. That's because all the information is packed into a tiny sliver of the overall image's information. So on the image's histogram, for example, look, it's just a tiny peak. So what we do is we apply a screen transfer function STF to stretch that histogram out so we can see what's actually in the image. So let's apply that to each channel now and have a look at what we're dealing with. Okay, well, as expected, red, green and blue don't look that interesting. However, I think the hydrogen came out really nicely here. You can clearly see the Tulip Nebula nice and bright there, and we've got all this interesting stuff going on, the interstellar medium. There's lots of dust and detail in there that we're going to be able to pull out. Not so much in the sulfur, but that's okay. Hydrogen's where all the detail will be. We can combine it with the sulfur to put a nice colour image, and with our oxygen we've got like a nice bright bit here for the core of the Tulip Nebula, and over on the right here we've got an interesting feature that's produced from like a Wolf-Rayet star, so we'll cover that later when we look at the final image. But so the thing to do now is to start processing and building the final picture. So to begin with, what I'm going to do on each of the narrowband images, I'm going to minimize our broadband ones for the stars for the time being, because we will come back to those. but towards the end. So let's move these over here to the side. And what we're going to do now is apply StarXTerminator to each of these images. So we're going to remove the stars so we can just focus on the nebulae, the bit we're kind of most interested in. So I'm going to speed this up now to avoid boring you, but I'm going to apply, as I mentioned, StarXTerminator on each one. Okay, so with StarXTerminator ran, you can see, especially in that hydrogen image over here, that there's some real good detail coming through. Taking away the stars just makes it a lot easier to, it's less clutter, isn't it, to see what's going on in there. Got some strange little bright spots on the oxygen image over here. That will be our blue channel. This is probably due to sort of large, very bright blue stars. And StarXTerminator might be getting a bit confused there about what's actually a star and what isn't. Some of the halos we get on the stars might be coming through there, but we will handle that with a tool later on in the process. So the next thing to do is to apply something called linear fit. So what this does is it kind of levels the playing field between the three images. So with our hydrogen image, the signal to noise ratio is far greater than with sulfur and oxygen. If we zoom in here just into just a little region, for example here, and we apply the same zoom across the three channels, you can see hopefully just how much more noise there is in the sulfur and the oxygen compared to the hydrogen. It's a lot smoother in hydrogen, and that's to be expected because the hydrogen's just, there's so much of it in the nebulous region. So what we're going to do is we're going to apply linear fit now. So we're going to sort of level the playing field between the levels before we combine them into a color image. So this is quite simple. We just go find the process of linear fit. The reference image that we're going to use will be the hydrogen one because it's got the most information in there. So we'll pop that in here and we'll apply this to our sulfur. Obviously we don't need to apply it to hydrogen itself because that is the reference image. So we'll apply that to oxygen as well. And then the next step, as mentioned, is to bring those together now into one image through channel combination. So we'll find process, we'll go to all processes and go to channel combination. So in here, to build a color image, combine the channels, we need to assign our red, green and blue channels. So we, as I mentioned earlier, we're back at the beginning of the project, I'm going for a Hubble Palette approach here. So that maps your sulfur to the red channel. So we're just going to pull this into red, and you take your hydrogen and put it in the green, and you take your oxygen and put it into the blue. Then we'll press apply global, so it will make a new image for us. So this won't look very interesting. That's to be expected because we haven't done anything yet to the actual data to make it visible. This is still, as I mentioned, that screen transfer function is working. So if I reset it, these images are still essentially black. So we are done with these ones now for the time being. We can minimize them. We'll pop them down in the corner with the rest. And then on our combined image, we will perform an unlinked stretch. So this lets PixInsight decide what the best values will be for moving the red, green and blue channels around. And this is where we'll get an indication, looks very nice if I do say so myself, of what our final picture is going to look like. So as you can see here, we've got some good detail in here with some contrast adjustments. This will come out very nicely. But as you can see, we've got a hell of a lot of green coming through in this, and that is to be expected. We mapped our hydrogen to the green channel. So hydrogen by far the biggest signal. So what we need to do now is sort of tidy that up. But before we get there, we're going to use a script called Narrowband Normalisation, which helps with that. But I'm going to run BlurXTerminator, which is a deconvolution algorithm, and it's going to just tidy up all of this sort of nebulous region and make some of the details really sharpen up quite nicely. So my settings on this, if I reset it, we don't need to worry about stellar adjustments because there are no stars. We remove them, so we can whack that down to 0. Now I do need to assign a point spread function here, PSF, That essentially is a measure of roughly how wide stars will appear pixel wise. So off the top of my head, I know for my setup it's about 4.5. And sharpen non-stellar, which is what we want. These are non-stellar features. We're going to pop this to about 7.5. Let's go somewhere in the middle there. So I'm going to run this now. It will take a little while, so I'll speed it up for you. Now that has worked wonders. BlurXTerminator, all the exterminator tools written by Russ Croman are fantastic. I think they're worth every penny if you've got this far into the hobby and you've purchased PixInsight. I don't know why you wouldn't want these amazing tools. But look at the before and after. If we zoom in on the Tulip Nebula, for example, and I flick back, undo the process, look how much blurrier that is. If we flip it back on, it's really sharpened up those details. It's just such an amazing tool, this. So the next step is to run this through narrowband normalization, as I mentioned. So we're going to hopefully balance the colors a bit better. So to find that, I believe we go to processes, narrowband normalization, and we tell it what palette we're going for. We want SHO, which is the Hubble palette, like I mentioned. For lightness, a bit of debate whether that's useful or not. I actually find if you do a preview, let's have a look here. You can see what the preview looks like. It's doing a much better job of balancing those colors. If I flick between HA for the lightness, that did come out a bit funny. Maybe let's get rid of that. Try again. Oh, it's the same. Let's go with it off then. Obviously we don't want that weird thing to happen there. And here we get a bit of control over, do we want to boost the blues? Do we want to boost the reds here? So this is a great tool, this. So you can just play around, see what you fancy really. I might boost the S2 a bit, get some of those golden colors, not so much. That was a bit heavy. You can see up here in the corners we're getting some really strange, it's arguably too red. So if we tap that back down, that looks a bit more natural. We do want the oxygen to shine through a bit, but not so much that any sort of saturation adjustments we do later will sort of blow them out and it will look unnatural. So it's a working out a fine balance here of what you want to do. If we take it back to 1, the default, it looks okay, but I think maybe just a touch of it adds something a bit more into that region here in the Tulip Nebula. If we look, if we take off those changes, it's very green, obviously, and applying them makes the blue color pop a bit more. So I'm happy with that as a rough place to start. So I will click apply. There we go, we can get rid of the preview. So this is still in its sort of linear state. We haven't stretched the histogram still. So if I do apply, reset the screen transfer function, we still see with black, but we're making adjustments to those fine levels in the data before we make a permanent change to it. So if we do a unlinked stretch, again, this is an indication of where we're going with this image. So the next step is, I did mention down here, we've got these nasty sort of artifacts from StarXTerminator. I'm going to use a tool called Blemish Blaster by Astro. His suite of tools is fantastic. He's even got his own sort of standalone processing package as well now, which is great. But what I'm going to do now is use his tool Blemish Blaster, which I believe is on script, Astro Blemish Blaster. Just to give you an example of this, it's going to load our image in, I believe. Actually, before we do that, let's close this and rename this SHO. So we get, it's good to label your images, know where you are, where you're working. So let's go back to script, Astro Blemish Blaster, make sure that is selecting that. Yes, we can apply an auto STF. We may need to zoom out. I'm rushing ahead now. There we go. So if we zoom out, we can sort of match this, and the way this works is we'll find those nasty blemishes, and what we can do, I believe, let's read the instructions. So we can click and drag to move around here. Obviously we don't want this, so we need to get it just right. So remove it. If you hold shift and then draw like a circle over it. What it does is it analyzes the pixels around and will sort of average out over the blemish. So for example, if I press execute, you can see what it's done there. It's got rid of that weird blemish, and that's what we're going to get. So what I'm going to do now to save you watching all of this is go through and find all these strange artifacts and remove them. It's a bit of a painful process, so you know, you just got to hunker down and get cracking on it. Where's it gone? I've zoomed out from the image, there we are. But I will speed this up so you don't have to watch me do all of this. It'll take some time. Okay, so Blemish Blaster has finished. We can close this now. There we go. And this should close as well. So what we need to do now is reapply a stretch because we've changed it slightly. There we go. So this is more like it. We got rid of those strange artifacts. So the next step is to basically stretch this image now permanently. So as I mentioned, it's still dark. It's still that all the information is packed into a tiny bit of the image. So we're going to stretch that information out so that those colors and stuff become permanent. So if we click screen transfer function again, this is quite nice. So what we're going to do is we're going to look at the histogram of this image. We select it here, SHO. You can see like there's a tiny peak here. We will now apply a permanent stretch to this, so we can drag the screen transfer function onto the histogram window. The preview will look odd, but that's okay. We can get rid of that. We can press apply. So now it looks like we've ruined the image. However, the stretch we were doing using the screen transfer function is still being applied. So if we reset that now, this is what our image actually finally looks like. Whoops. So it's probably a good point now to save this. So if we go file, you don't want to lose any progress. So you can go ahead and press file, save as, and do what you need to do. So the next thing, if we zoom in, some areas are indeed quite noisy. So we can apply Ross Croman's other tool, NoiseXTerminator, and I'm going to run this 0.9. It's quite high. You do want a little bit of noise to be present in your image. If we do too much, it will look weird, like plasticky, like almost too smooth, and it will begin to look fake. So we do want a little bit of noise left in there. So I like to drag this down to about 0.6-ish. I basically just run it and see how it looks. Like, it's good to zoom in on an area of interest and see how that looks. So let's run that now. I'll speed this up because it can take a little bit of time. So I think that did a great job. If you flick back to how it was before, you can see it's quite grainy in areas. If we flip to how it is now, there's still a bit of noise, just enough to tell us this is a real image and it hasn't been faked, for example. So what we'll do now is we'll apply some selective color correction sort of stuff, boosting some of the colors, applying contrast here and there. So there's a tool for this, I believe. I'm not sure it's a process. I need to find my way around better. Script utilities. Let me find it. Toolbox. Selective color correction. It was in the toolbox. So what this does is obviously working around off doing crazy stuff over here, but we can apply, say, if we look at our image, we want to sort of bring out a bit more detail in these areas. If we're out the middle in all this dust, so we can find, say, a yellowy mask. It's all about playing with it now. Like these are all, this is where your artistic flair comes in. How much detail do you want to produce? So we've done a yellow mask here, and we can apply sort of contrast changes here. Probably help if I make this a bit larger so we can really see what's going on. If I move over, we can see where is it? So if we go to saturation or contrast, we pop this up. This should give us a little preview of what we're doing as we go. That looks quite nice. If we go show mask as well, you can really see where we're applying these changes. So because it's a yellow mask, it's really picking up that Tulip Nebula. So I might actually mess around with, if I press, yeah, that was okay. I didn't really change much, but we can play around with the mask parameters to see if we can capture more of those regions throughout the middle of the image. So yellow is probably not the best one to use. Let's see if this does anything. So again, it's a lot of playing around now, trying to work out what you want to do to the image. Perhaps if we go for a green mask instead, we can see where we're selecting. That's not working so well. Maybe red will do us better. Potentially. Yellow was working a bit better, wasn't it? Intensity, whack that up. There we go. So now, if we're applying some contrast changes, we should see those happen on a much wider scale across the image. That's looking quite nice. We can also bump up the saturation a bit as well. Yeah, that's cool. So we press apply, let it do its magic. There we go, that's finished, so we can close that. This is looking quite nice, and we can do some small adjustments to it now. For example, if we open the curves tool, we can open a preview, see what we're actually doing. And you know, small changes work quite well in this. We don't want to make huge changes, and it will make it difficult for us to unpick what's going on. So if we pick all the channels here, we can apply a small S curve, for example, make the darks darker, make the brights brighter. For example, we can toggle this on or off. I think that's done a nice touch. It's quite subtle, but yeah, we can apply that, see if it can take another round of that. I argue it can, so let's run it again. It's cool. Another round might be a push too much, so if we reset the tool, we could go to saturation, for example, and bump up the colors overall. So if we have a little zoom in on the tulip region, that was a poor selection there, wasn't it? Let's try again. Obviously this is where your eye is going to be drawn to in the image. We can turn the preview off and on to see what's going on. I'd argue that might be a bit too much, so you know, you want to be subtle with these changes. So I will apply that as I quite like it. And also, like, we want to pick up the blues, we want to really let them stand out, for example. But I would argue this blue region in the bottom right corner is getting a bit busy. Busy in terms of sort of saturation and brightness there. We don't want to overblow it, but I would quite like for the blues in the tulip to pop a bit more. So the way we can do that is if we close the curves transformation briefly, we can create a blue mask. Actually, let's create a luminance mask, for example. So we go to mask generation, range selection, so and open a preview. Obviously that's not very good. We need to adjust things. We want to pick out that tulip region. Yeah, so this is our tulip region here. We only really want to focus on that, so I'm not interested in all the rest. So this is where it gets a little bit tricky. We do want to apply some fuzziness and smoothing to the mask. We don't want our changes to be quite so sharp in certain areas. So let's adjust this some more. I'd say that's okay, because we do want to focus on tulip. We're not interested in everything over here. So rather, it's going to be tricky, but we're going to apply this, generate our mask. And I'm not interested in all the stuff over here on the right. So this is where it's a little bit annoying. There's probably better ways to do this, but the way I do it is go to clone stamp tool, and I'm just going to see how big the tool is. I'm going to whack this up quite significantly. I suppose I need to pick somewhere first. So that's too small. I want it to be a lot larger. And now it's just a case of getting rid of everything that I'm not particularly interested in capturing with the mask. So it is a bit of a faff, and I will speed this up to save you watching my painful drawing over all of this. Okay, so our mask is pretty much done, so we can finish the clone stamp, close this. We're going to apply the mask now to the image. We'll pop it over here, we'll see it goes red. Basically everything not red is where our changes will be made. So let's open up curves again, apply a preview. So just as a demonstration, because it's a preview, if I were to like do something crazy with the luminance levels of the image, like drop it way down, you can see the mask is protecting everything apart from where we've let it like apply changes. So obviously that's a crazy change. We don't want to do that. But if we zoom in over the Tulip Nebula, we can, you know, perhaps bump up the brightness of the nebula just a tad, and we can come over to those blues and push them up ever so slightly. So we can apply the before and after feature here. You can see we've brightened it probably too much. So let's come back here, reset this one, and let's just see if our change to the blue. I think the change to the blue alone is doing a nice job there, really making that oxygen signal stand out a bit more within the core without overblowing what we were seeing in the bottom right hand corner. So let's apply that. There we go. And we can remove the mask. And we can also get rid of this now, as we're not interested in it anymore. So yes, this is our image. Now what we're going to do now is just continue making small adjustments here, you know, making colours stand out slightly more. We have these handy tools where we can just drop, say, a yellow mask over this, and it will analyse the yellow colours and produce a nice mask for us if we wanted to apply this on it and make any further changes to colours and what have you. I think it's looking pretty good as it is. I might just have a look, because if you zoom in this top left corner where essentially it's just the background level, it's quite red, so some of that sulfur stuff is coming through there. So if we apply a preview, we might be able to sort of balance the the dark background signal a bit more. So if we go to red, we can see if adjusting the histogram slightly in either direction. Let's reset it. That was a wrong move there. There we go. We're pushing it upwards a bit more, bringing it in. I think that's a nice touch. It's just taking a bit of that red noise out of the whole thing. So again, if we flick back and forth, I think that does a nice touch there. So let's apply that. We won't do it again though. We don't want the color channels to be too off balance. So yeah, now it's just a case of making small adjustments here and there, improving what you're seeing here. So yeah, one thing we will cover now is like adding in our RGB stars back into the image. So I will save this image so we don't lose it. So let's jump up to my directory here. We'll call it processing. Just call it SHO. We don't want a TIFF file, that'll lose all our information. So we'll save this. Now let's minimize this and work on our RGB stars. So if we open these up, here we are. First step on this, we don't need to do all the balancing like we did with linear fit at the beginning, so we'll just apply a channel combination on this to make a color image. And this time I'm just going to write RG and B in. We're not doing anything fancy with this, so we'll press run. Oh, it's good, isn't it? There we are. Wrong button. So again, we're done with these essentially now, so we can minimize these. And if we apply an STF, a screen transfer function, on our RGB, actually let's relabel it RGB. We'll do an unlinked one. We'll let PixInsight decide the best sort of way to balance the levels. So you can see it's pretty boring. You can see the Tulip Nebula in here. It's a cool picture. There's lots of stars. And a good practice now would be perhaps to run like a gradient correction tool on this, because there were some nights where the moon was quite bright. That might influence the blue channel somewhat. So I like to run script, toolbox, GraxPert, and we'll just see if we like the before and after. It might not be necessary, but let's run this. Okay, so that has shown us that there was somewhat of a gradient to the image, and I'm happy with how it looks after. So we're going to run with this. We'll say the gradient's been corrected now, so we can close that. The next step is to color calibrate the image, make sure all the channels are correct. So what we're going to use for this tool is the spectrophotometric color calibration. It sounds very fancy, just abbreviate to SPCC, but basically all this does is because there's information buried in the metadata of this image about where in the sky it was looking, it will compare the colors we're getting here to known surveys by professional astronomers, and will sort of balance the colors much better than we'd be able to. So if we go to process, go to spectrophotometric color calibration, we can pop in here our filters that we were using. So I was using Optilong filters, so we can pop those in. And we need a region of interest for the background. So what we'll do is we'll zoom in. We know in the top left it was prettier, there wasn't anything interesting, so we can use that as our background reference. We'll just pick an area up around here, for example, and we can go region of interest from preview, and there's that little preview box that we've just generated there. So cool. If I zoom back out now, we'll let SPCC run, and then we'll review how it looks. Okay, so SPCC always gives you this graph as an output. I mean, I think you can uncheck this box here, but general rule of thumb is you want to see all your stars more or less on this positive skew, like correlation along this line. If you don't see that, it means there's something funky going on. I'm not going to go into too much detail here, but this is good results. So cool. We'll close that. We'll close this. Now the image looks strange because we've now sort of color calibrated it, and the screen transfer function is not going to work anymore. So if we reset it and do a linked stretch now, so that makes sure our channels are all going to stay together as per the results of SPCC, we'll see what the final image for this will look like. So that's a lot better. Cool, we can get rid of the preview as well. We're not interested in that anymore. Now the next step is to run BlurXTerminator on this as well, so that deconvolution algorithm. Let's zoom in and have a good look at this. So we use the automatic PSF this time because there are stars where it can work that out. We don't need to do anything else. We're going to sharpen stars, whack that up quite high, because this is all we're using this image for, is the natural star colors. We're not interested about sharpening non-stellar, so we can reduce that. And so yeah, I'm going to drag this over now, run this, I'll speed it up. Cool. So again, what a fantastic thing BlurXTerminator is, because if we have a look up here, like in the corners where the stars were particularly troublesome, let's go undo, see what it was before. You can see how smudged they were. There was some kind of element of tilt in the system, which means the stars start taking on this sort of egg sort of shape. But if we flip forward to after, you can see that's done a great job of tidying up those stars for us. Excellent. So we don't need BlurXTerminator anymore. Now what we need to do, if we open up screen transfer function again, is that this is still hang on. There we go. This is still a linear image. It's not been stretched. So what we need to do now is to bring out all that detail in the star. So I'm going to use a tool called GHS, Generalized Hyperbolic Stretch, for that. So here we are. So as you can see, this is the histogram. All that data is just buried right up against the left side of the histogram. It's all buried in here. So generally speaking, I'm just going to pick a symmetry point roughly in the middle of all the information. I'm going to open up a preview as well. And we're just going to stretch this now until our stars start to appear and look good. So let's zoom back out so we can see what we're doing to the histogram. There we are. We don't want to push it too far. Like if we overblow it, the stars, everything gets too bright and we start oversaturating things. So a good sort of rule is to sort of zoom into an area where there's some busy star stuff happening, and we can have a look and see. You kind of want, so if we look here, you can see there's a lot of stars that are sort of separate when you don't stretch it so much. We don't want to lose that information that there's other stars there. We inevitably will though, because those ones are quite bright, but we can try our best to adjust for it. If we increase the local intensity, for example, it means we're sort of lowering how bright the cores are. Do you see there? If we do a preview and a preview, like we can actually see this star and this star separate from this main one here. So let's zoom back out. That's okay for the first round. So if we can apply that, that's cool. We'll reset the tool. And then what we'll do again is we'll pick somewhere in the middle for a symmetry point. And we'll just zoom in again, or just make an adjustment here to see if we can bring out a few more. Don't want to go too crazy, but this is looking okay. I might even actually, let's zoom in and have a closer look at that busy area again. See if we can push it a bit further. I think that looks good. So let's run that. Cool. So now we have our stars. That looks quite good to me. And what we're going to do now is run StarXTerminator, but generate the star image and leave behind the nebulosity in this image that we're not interested in anymore. So let's go to StarXTerminator. We do want to generate a star image. I always tick large overlap because it means the algorithm will work on smaller regions and produce better results generally. So I'm going to run this and speed it up so you don't have to watch me waiting. Okay, cool. So we've got one image here generated that's got the sort of nebulosity stuff that we're not interested in, so we can close that. We don't want it. We can close StarXTerminator, and here are our stars, RGB stars, so natural looking stars, color calibrated as well. So now all we've got to do is open up the curves tool and just pump up the saturation on this to really let those star colors shine through. So again, let's open up a preview so we can see what we're doing. We zoom in on like a nice area where there were some big stars. We'll pop over to saturation, and we will go a bit mental on this. We will increase it quite significantly. So you can see those red stars really do start to appear red now. Maybe that's a stretch too far, because we don't want to oversaturate things. But again, smaller changes, but more of them is a better approach with this sort of thing. So if we press apply, that's quite nice. We can see here there's some actual variation in the star colors. If we zoom over, you can see there's some red ones, there's some blue ones, so there's a bit more interest happening now. If we turn it off, we can see where we were. If we turn it on, we can see the changes after. I'm happy with the changes again with another round of the same level of saturation increase, so I'll run that. And I would say perhaps a third round would be a bit much. You can really see those orangey reds are a bit much now, so if we reset, let's go with that. So cool, we have our stars with saturation that we're happy with. So now all we need to do is open up our nice nebula picture along with our stars here, and we need to combine them. So what we're going to do for that is a process called PixelMath or PixelMath. So we go process, all process, PixelMath. There we go. Sorry, British thing, maths rather than math. Cool. So we will open this up and we will generate a new image, and we will call it SHO for our narrowband image underscore RGB for RGB stars, for example. And the expression that we want to put in here is combine. Let's actually pick this one, that's the target image. So we'll put $T. That references the image I selected. And then we'll put in what we're going to combine it with. So that was RGB stars. So that's this image behind, this one here. And the operation we want to run on it is op_screen. And now let's run that. Oops, wrong button again. I always do that. Let's run this. Oh, okay, doesn't like it. Let's reset it. I obviously missed that I had an expression in there beforehand. So let's go SHO RGB stars. Combine $T RGB stars operation screen. And let's run that. Did it wrong again. Is it? I need to pick this image first and then run it. There we are. Cool. So I'm really happy with how it's looking now. We can minimize these. And well, yeah, I think this looks great. A few more adjustments needed to some of the colors, perhaps some of the contrast levels. One thing that is annoying me is that I would rather see it the other way around. I want the Tulip Nebula to be facing like sort of upwards rather than downwards. So we can just do a fast rotation here, rotate it 180. There we are. So I think that looks a bit nicer. But at this point, I would be quite happy with this final image. One thing I tend to do though is I'll do this whole thing maybe 3 or 4 times. It's good now to save the image and then go off for a few hours and come back and look at it. My opinion on it changes until I settle on it and I'm happy with it. I'll do renditions of this, but generally speaking, that's the process I would follow. So all I'm going to do now is continue making some small tweaks, small changes here or there on the curves, just to bump up the saturation. I might even export it as a TIFF and run it through Photoshop on the camera raw adjustments. They're quite handy, quite nice. But yeah, so I'm going to just carry on making very small changes to this, see if I can push out any more information such as small S-curve sort of things to bring out a bit more contrast, for example. But I'm going to crack on with that, and then hopefully I'll share the final picture with you. So yeah, that's what I'm going to carry on doing now, and hopefully I'll share a final image with you shortly. And there is the final image of the Tulip Nebula and its dusty surroundings in the Cygnus constellation. I'm personally very happy with how the image turned out. I hope you are too. And if you've made it this far in the video, I just want to give you a huge thanks for watching, because I do appreciate it. It was a very long video. This sort of processing tutorial kind of video, they're always long videos. There's just so much to consider when doing narrowband processing, especially when you go in and add in some RGB stars towards the end. So thank you very much for watching, and I'll pop a link in the description. I think I popped a card up earlier to part 1 of this sort of video, where it's a lot more compact, and I do like a zoom in towards the end where I talk about some of the cool objects in the image. So do check that video out if you haven't watched it already. But yes, I appreciate very much for your time. As you can probably see and hear, the rain is quite heavy. The weather has taken a turn for the worse lately in the UK, especially down in the southwest. No time for astronomy, unfortunately. It's far too risky. There are gaps in the clouds, but it's just not worth the hassle and the risk of getting all the gear caught in a rainstorm. But I will leave you there. I'll let Bruce get back to his snooze. Thanks again for watching, and as always, if you go stargazing yourself, I wish you clear skies.